In Unit 6.2, we are going to learn all about the unit circle. And before we start to build this in class, I want to do a little bit of background information so that we are just ready to start looking at patterns as we build our unit circle. So in geometry, we learned about two special right triangles. One of them is a 45-45-90 right triangle, and one of them is a 30-60-90 degree triangle. Now, I want to talk about these and kind of talk about their sides and the lengths of the sides and the angles, but I'm going to do it on the very first page. This is back page 160 to the start of this section, just because there's a little more space here that I can use to draw and label my triangle. But first, that 45-45-90 degree triangle. Okay, what that means is, I'm going to do this here. We have two angles that are both 45 degrees and one angle that is 90. Okay, so this is... Now, if I look at the sides that are opposite two angles that have the same measure are going to be congruent. All right, so when two angles in a right angle are equal, the opposite sides also have to be equal. All right, so if I were to say, and again, we're going to talk a little bit in class, we're going to talk a lot about the unit circle. So when we talk about the unit, we talk about the radius in the circle being 1. So if I say that each of these sides has length of 1 unit, and we want to calculate the side of the hypotenuse in this right triangle. So we're going to use the Pythagorean theorem, and we're going to have 1 squared plus 1 squared equals c squared, because that's the hypotenuse. So this is 1 squared plus 1 squared is 2 equals c squared. So c has to equal the square root of 2. Okay, so when I have a 45-45-90 degree triangle on the unit circle, the lengths of my sides are 1, 1, square root of 2. So we're going to put this on the other side. Okay, and this is back to page 164. So remember, these sides that are opposite of these angles that are the same, that are 45 degrees, these sides opposite of them have to be equal. So this is 1 unit, and this is the square root of 2. So in a 45-45-90 triangle, the sides are 1, 1, square root of 2. Now in a 30-60-90 degree triangle, we actually start off with an equilateral triangle. And if you remember, in an equilateral triangles, all sides are the same, but so are all the angles. And if all the angles of a triangle add up to 180, if I divide that by 3, each of these angles has to be 60 degrees. Okay. Now, to get my 30-60-90 triangle, I'm going to drop a perpendicular bisector through this angle and through the opposite side. Okay, and there's my right angle. I cut this angle in half, so this angle now is 30, this angle is 60, and this angle is my right angle, which is 90. So really what I have here is this triangle, where this is 60, this is 30, this is 90. Now, if each of these sides are the same, then these lengths of the big triangle are length of 1. So this side of this triangle is length 1. This side, because I dropped a perpendicular bisector, it also bisects this segment. This side would be 1/2, and I don't know the length of this side yet. But if I use the Pythagorean theorem here, I have a squared plus 1/2 squared equals 1 squared. All right, so this is a squared plus 1/4 equals 1. And this would be a squared is 3/4. So a is the square root of 3 over 2. If I square root both sides here, square root of 3 over square root of 4, which is 2. So this side right here is the square root of 3 over 2. Now, instead of working with all these fractions here, these are all proportional. So if I multiply each of these by 2, my sides are going to be, this is 1, this side is 2, and this side is going to be the square root of 3. All right, so 1, 2, square root of 3. So let's put that onto this triangle. So here's my 90, this is my 60, this is 30. 1, 2, square root of 3. Remember, if this were an equilateral triangle, this is the longest side, which is 2. This side is half of this side, this is 1, and this side is square root of 3. So down below we have our 6 trig functions, and right now I don't really want to look about the y's and r's and x's. What I want to think about is SOHCAHTOA, SOHCAHTOA. And SOHCAHTOA is just a mnemonic device that helps us remember the trig ratios. So if I want to find the sine of an angle, I'm going to look for the side that's opposite over the hypotenuse. Opposite hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of the angle, and I'm just going to put theta in here to represent an angle, is opposite over adjacent. Now, these we're going to talk about later on. In the unit circle, we really mostly talk about sine, cosine, and tangent. Secant, cosecant, and cotangent are just the reciprocals of these. So basically, I'm going to flip, and I can write those over here. This would be cosecant is the reciprocal of sine. So I have hypotenuse over opposite. Secant is the reciprocal of cosine, which is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which would be adjacent over opposite. So if I'm using a triangle, and let's look at this 45, 45, 90 triangle. If I wanted to find sine of 45 degrees, I'm going to look for the sides that are opposite and the hypotenuse of this 45-degree angle. So the side opposite, and it doesn't matter which one I pick because the side opposite is the same. So the side opposite of that 45-degree angle is 1, and the hypotenuse is square root of 2. So I have 1 over square root of 2. It's not good math manners to leave the square root of 2 in the denominator. So we're going to rationalize the denominator by multiplying by the square root of 2 over square root of 2. This gives me 2 on bottom, square root of 2 over 2. Now cosine of 45 means to take your 45-degree angle, look for the side opposite, which is 1, over the hypotenuse. So this is 1 over square root of 2, which is the same as what was up here. So this is also square root of 2 over 2. Tangent of 45 degrees, that's a 4. Opposite over adjacent. So I have 1 over 1 is 1. All right, so now we can look at 30-degree angle. So if I look at sine of 30, I'm going to look at my 30-degree angle. That should have been 60. Opposite over hypotenuse. The side opposite is 1, hypotenuse is 2. So this is 1/2. Cosine of 30. Cosine is the side adjacent, which is square root of 3, over my hypotenuse, which is 2. And tangent of 30 is the side opposite, which is 1, over the square root of 3, the adjacent side. Okay, so again, we don't want to leave our square root of 3 in the denominator, so I'm going to multiply top and bottom by the square root of 3, and that gives me the square root of 3 over 3, and that's the tangent of 30. And last, let's go ahead and do 60 degrees. Sine of 60. Sine is opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is adjacent, which is 1 over 2. And tangent is opposite, which is square root of 3 over 1. Okay, so we're going to stop right here, and in the next class we are actually going to use a bunch of patterns to help us build the unit circle.